So in this lecture I'm going to talk about comparative advantage and different forms of government by allegory. Alright, so first of all, I'm going to do it all through an allegory of two baristas. Alright, so we're going to have two baristas. The first one is going to be a very efficient barista. Alright, and this guy can make a lot of lattes. This guy can actually make either 60 espressos per hour or 60 steamed milks per hour. Or any sort of combination of the two. You can do 30 espressos and 30 steamed milks, or 20 espressos and 40 steamed milks. Any sort of linear combination of those two numbers. All right. We should write per hour. All right. Then we're going to have a poor barista. This barista is not so great because this barista is feeling really tired. Didn't get a good sleep last night. All right. Didn't have time to shave, for example. All right. And this barista can either make 20 espressos per hour, or alternatively 40 steamed milks per hour. Alright, and I think one thing to note here is that this barista is worse than the efficient barista at both making espressos and making steamed milks. Alright, so what I want to think about first is, suppose these two guys are in autocracy. Oh, excuse me, in autarky, not autocracy. In autarky. Autarky. Alright, so what that means is that each one is going to be making as many lattes as they can. I didn't mention that, but in order to make a latte, you need to have one espresso and one steamed milk. Alright, 1 unit, let's say. Alright, so we're going to see how many lattes can be made total if each of these people is making as many lattes as they can, but just only by themselves. So they both have to make their own espresso and their own steamed milk by themselves. Okay, so we're going to call that autarky. Okay, so first let's go with the efficient barista. Efficient barista. This one's really easy. Since we know that the number of lattes has to be the same as the number of steamed milks, this person can make either 60 espressos per hour or 60 steamed milks per hour. Well, that means that they're going to spend half the time making espressos and half the time making steamed milks. So they're going to end up with, without doing any sort of math, this guy's going to end up with 30 lattes per hour. Okay. Now let's talk about the poor barista. This takes a little more calculation. Alright. So we're going to define right away T. I'm just going to call it T. It's going to be the time making espresso. So the poor barista is going to spend some of his time making espressos and some of his time making steamed milk. We don't know exactly how much time is going to be spent making espresso and how much time is going to be spent making steamed milk. We have to try to figure it out. Okay. So in fact, maybe I'm going to call this TE, and I'm going to call TM the amount of time making steamed milk. Well, that's going to be 1 hour total, minus time spent making espresso. So it's going to be time making steamed milk, or just milk maybe in the future. Okay. So we know that there has to be the same amount of espresso and the same amount of steamed milk at the end of the day, because if you have more espresso than you have steamed milk, you can only make as much latte as you have steamed milk. Right, so that would be wasteful. Also, if you had more milk than you had espresso, you'd also be wasting some of your milk. So you need to have exactly the same amount of espresso and steamed milk to make a latte in my allegory here. Okay, so what we can do is we know that the amount of espresso that this person makes, which is 20 times the time spent making espresso, right? You can make 20 espressos an hour. So if TE is the fraction of the hour spent making espresso, then the amount of espressos he's going to get is 20 times this fraction. Okay, that has to be equal to 40 times the time spent making steamed milk. All right, and then we can replace this Tm with 1 minus Te, right? So 41 minus Te. All right, then we can just solve for Te. So we're going to take that 40 to the other side. We're going to get 60 Te is equal to 40, or in other words, Te is equal to 2/3. Okay, so this says that the poor barista is going to spend 2/3 of an hour making espresso and 1/3 making steamed milk. Okay, so how much total is this person going to make? Well, let's see here. Let's plug in 2/3 for espresso. So we're going to get 40 divided by 3. Okay, so lattes per hour are 40 divided by 3, which is approximately equal to 13. Well, it's exactly equal to 13 1/3. Okay, so how much, so total in the market, so total amount of lattes is 43 1/3. Okay, so you got 43 lattes and 1/3 cup of a latte, 1/3 of a latte at the end of the hour. All right. Next, let's consider a latte-maximizing dictator. Okay, so this is going to be the situation. Sometimes I used to call this socialism. Maybe it's not the best way to describe it, but the idea is you've got somebody who's at the top, the planner, and this person is going to be dictating how much time each of the baristas is going to be spending on making each of the espressos or steamed milks in order to maximize the amount of lattes. So you can think about this dictator as the latte maximizing dictator. He's going to do whatever he can to maximize the amount of lattes in society. All right. So you can think about it as, yeah, I'll just call it that, a dictatorship. Okay, so I'm going to call it latte maximizing dictator. Oops. Dictator. All right, so how is this person going to do it? How are we going to set up the problem for this latte maximizing dictator? All right, so let's start by thinking about the amount of time that let's call the efficient barista, let's call that barista number 1, and the poor barista, we'll call that barista number 2. All right, so let's start with some notation. So by T1, I'm just going to call that the amount of time of barista 1, so we can remember which one's which, I'll say the efficient barista of efficient barista making espresso. So I dropped the E there just because I don't need that notation. Let's just only use this T1 to mean the time making espresso, just because then I don't have to have these E's and these M's floating around. All right, and then we'll do the same thing for T2. That will be the time of the poor barista making espressos. Okay. So now the benevolent dictator, they want to maximize the total amount of lattes, right? And the thing is, we know that at the end of the day, the amount of lattes we're going to get is also the same as the amount of espressos we're going to get, or alternatively, as the amount of milks we're going to get. So, so let's just say they're going to maximize the number of espressos. So we're going to have the benevolent dictator's problem. It's going to be to maximize T1 and T2 the number of espressos. So how many espressos are we going to get? It's going to be 60 times T1, right? So 60 times the amount of the hour that barista 1 is spending making espressos, plus 20 times T2. Okay, 20 times the amount of the hour that barista number 2 is making espressos. Okay, so we want to maximize this expression. subject to a constraint. What's the constraint? Well, we know that to make a latte, you need to have exactly the same amount of milk and espresso, and if you don't have that, then there's going to be waste. All right, so we want to make it so that the number of espressos, like we just wrote, in society, is going to be equal to the amount of milk in society. So that's 60 times 1 minus T1, right? Any time that's not spent making espresso by barista 1 is going to be spent making milk, plus 40 times 1 minus T2. All right, so far so good. Now, when we've got a maximization problem like this, really the easiest way to solve it is going to be to try to substitute out one of the numbers. All right, so let's substitute out T1. So let's try to write T1 in terms of T2 using the constraint. Okay, so we're going to isolate T1 on the left-hand side of the constraint and then plug it into the maximization problem. Okay, so we're going to try to isolate T1 here. So let's see here, we're going to have 60 T1 on this side, and here we're also going to have negative 60 T1. So it's going to be 120 T1 on this side, on the left-hand side of the equation. We got a 20 T2 here. Here we've got a negative 40 T2. So we're going to have a negative 60 T2 on the other side of the equation. Okay, and then we got a 60 plus 40, so plus 100. Okay, so we're already done. Oh, not quite. Now we have to divide through by 120. And we're going to get, let's see here, it's going to be 100 divided by 120. Okay, so that's going to be 5/6 minus 60 divided by 120, that's going to be 1/2 times T2. All right, so now let's plug this expression for T1 into our maximization problem. Okay, so we'll make a line here. We're going to plug this expression up here into this maximization problem. So we're going to replace T1 here. So we're going to get max, and I'm going to drop this max in a second, T2, because we're going to replace T1 with T2 here. 60 times 5/6 minus 1/2 T2 plus 20 T2. Okay. So now I'm just going to implicitly have this max here, but let's just do a little calculation. So we're going to get 50 minus 30 T2 plus 20 T2. Okay, so we're going to get 50 minus 10 T2. All right, and now I'm going to put that max back in here. Okay, so now here's the question. What's the maximum value of this expression we can get with a T2 between 0 and 1, right? So there's 1 hour to spend. What fraction of the hour do we want the pour barista to spend making espresso? And you can see, since there's a negative sign here, actually what we want is oops, that's not equal sign there. What we want is that the pour barista doesn't spend any time making espresso. We maximize this expression when T2 is equal to 0. All right. So we know that the pour barista is going to spend all of their time making milk. Okay. So now, since we know that T2 is equal to 0, and we're maximizing T1 and T2, we can come back to this original expression, and we can think we want to maximize. Wait 1 second here. So we can look down here. Okay, so here we've got T1 is equal to 5/6 minus 1/2 T2. T2 we've just determined is equal to 0. Maybe I'll write it here so we remember. T2 star is equal to 0. That means that T1 star is equal to 5/6. Okay? From the constraint. All right, so now what's the total number of espressos we get, which is equal to the total number of lattes we get? It's just going to be 60. Okay, T2 is 0, right? 60 times 5/6. So the number of lattes, which is equal to the number of espressos, is equal to 60 times 5/6 equals 50. Okay, so we get 50 lattes at the when the dictator is trying to maximize the amount of lattes. So the dictator is telling everybody what to do, and he can actually do better than we could do in Autarky, right? In Autarky, we've only got 43 1/3 lattes. Here, when the dictator is directing people about what to do, the dictator can actually do better. The dictator can get 50 lattes. Okay, so he can basically, if you kind of think about what's happening here, he's basically telling the poor barista to not spend any time making espressos because the poor barista is just so bad at making espressos. It's like, rather than having the poor barista waste time on, waste lots of time to make one espresso, the dictator says, you know what, it's better for you just to focus on steamed milk. You're not that great at making steamed milk. The efficient barista is better, but you're even worse at making the espresso, so just don't do that. Okay, spend all of your time focusing on steaming the milk. All right, and doing that, we can actually increase the number of lattes we get at the end of the day. Okay, so this is the latte-maximizing dictator. Now, where am I going with this? We started at autarky. Now we've talked about a latte-maximizing dictator, or maybe a benevolent dictator, if you like. Now let's think about what would happen if there was a market for espresso and milk. Okay, so now there's not going to be anybody telling anybody what to do. We're just going to have a market that's going to have prices, and we're going to see what happens with the number of lattes we're going to get when we have sort of a perfect market. Okay, so let's try that next. The last step. Alrighty, got some notes here. Let me just scroll down. Okay, so again, we're going to have a market where the two baristas can sell espresso and sell steamed milk, and we have to think about what they want to spend their time doing depending on the price. Okay, so let's start with the efficient barista. Okay, so this efficient barista, what are they going to think about it? All right, so basically the efficient barista wants to compare 60 times the price of milk with 60 times the price of espresso, right? So I mean, if the price of espresso is the same as is higher than the price of milk, then this efficient barista can actually make more money by only making espresso, right? Don't waste any time making milk, just make more espresso. On the other hand, if the price of milk is higher than the price of espresso, then the barista is going to only want to make milk. Okay, and if the price of milk and espresso is the same, suppose the price is whatever, 1 kroner for milk and 1 kroner for espresso, then the efficient barista doesn't really care. They can spend some time making espressos and some time making milk, all their time making espresso, all their time making milk. It's indifferent. They're going to make the same amount of money either way. But when the prices are different, they're gonna want to make one or the other. Okay, so let's formalize that by writing it down. Okay, so if the amount of money that the efficient barista can make, so PE here is for the price of espresso, not efficient. If the price of espresso times 60 is greater than 60 times the price of milk, then, or in other words, here's pulling my notes a little bit, if PE divided by PM is greater than 1, okay, you just do a little division over there, then that means that the efficient barista is only going to make espresso, right? The price of espresso is higher than milk. Why would you waste time making milk? You'd rather spend your time making espresso. You're going to make more money. All right. Now suppose that 60 times the price of espresso is less than 60 times the price of milk, or in other words, PE divided by PM is less than 1. Now the efficient barista only wants to make milk. All right. Then finally, if the price of espresso is exactly the same as the price of milk, in other words, PE divided by PM is equal to 1, then this barista is going to be indifferent. They can spend all their time making one, all their time making the other, or some combination. It's all going to end up paying them the same amount of money. Right? Now, let's consider the situation of the poor barista. All right, this is different because the productivity is a little different here for the poor barista. Right? So now the poor barista is going to want to compare, let's see here, it's going to be 20 PE with 40 PM. All right? So let's do the same sort of calculation here. If 20 PE, we don't know what the price of espressos is, but if 20 PE is greater than 40 PM, in other words, if PE divided by PM is greater than 2, let's just take a look here, yes, then this pour barista is only going to make espresso. Okay. If 20 PE is less than 40 PM, in other words, PE divided by PM is less than 2, then this pour barista is only going to make milk. And then finally, just the same as with the rich barista, or the efficient barista, I should say, so PE divided by PM is equal to 2 in difference. Okay? Now let's remember these numbers. Everything that matters for the rich barista is the comparison of the ratio of the price of espresso to the price of milk compared with 1. All right? Everything that matters for the poor barista is the price of espresso divided by the price of milk compared with 2. Okay? And if if we're greater than 1, it means that everybody, or if we're greater than 2, I should say, everybody wants to make espresso. If the price of espresso divided by the price of milk is less than 1, then everybody wants to make milk. And if the price of espresso is strictly in between 1 and 2, then the efficient barista is going to want to make espresso strictly, and the poor barista is going to strictly want to make milk, not want to make any espresso at all. Okay, so that's kind of the situation we're looking at here. And now I'm going to formalize that in a graph. I'm going to draw it in a graph. Okay. So again, just to remind you where we are, we're in the market. Okay, so now we're going to do a graph that's sometimes called relative supply and relative demand. Okay, so we're going to have the relative price of espresso on the y-axis, and on the x-axis we're going to have the relative quantity in the whole economy of espresso versus milk. Okay, so there's going to be 2 important numbers here on this price. It's going to be 1, right? That's what matters for the efficient barista. And we're also going to have 2. And that's what matters for the poor barista. Okay? So now let's consider what happens when we have different prices. All right? So as we just talked about, if the price of espresso relative to the price of milk is less than 1, then it means that everybody in the whole economy wants to make milk. Right? So the amount of espresso in the economy, the quantity of espresso in the economy is equal to 0, and the quantity of milk is positive. So we're going to be hanging out at this part of the graph, all right, until we get to 1. 0 espresso, some positive amount of milk. Everybody's making milk. Right? Then once we get to 1, we're going to then now suddenly the efficient barista is indifferent between making espresso and making milk. So, now the efficient barista could be making some espresso. So any amount of espresso up to the point where the efficient barista is spending all of their time making espresso, and now still the poor barista is spending all their time making milk. Okay, so we actually know what number that is. We can figure it out. So down here, if the rich barista, or the efficient barista, rich and poor, I should have chosen something that was the opposite so I wouldn't keep screwing that up. Efficient, inefficient, rich, poor. But now I've got the efficient barista and the poor barista. Anyway. All right, so the efficient barista is spending 1 all of their time making espresso. So that means we're going to get 60 espressos, right? And the poor barista is spending all of their time making milk, which means we're going to get 40 milks. So the total amount of espresso in the economy is 60. The total amount of milk in the economy is 40. Okay, so this number happens to be 3 halves, right? Is equal to 3 halves. All right, so the relative quantity of espresso when the efficient barista is spending all their time making espresso and poor barista is spending all their time making milk is exactly 3 halves. Okay. Now, that's going to be true, right? If the price goes above 1 but stays below 2, then the efficient barista only wants to make espresso. They're comparing everything with 1, right? So when the price of espresso relative to the price of milk is greater than 1, as we saw in the last slide, the efficient barista only wants to make espresso. Okay, when the price of espresso relative to milk is less than 2, the poor barista only wants to make milk. All right, so that's why we're sort of stuck on this line here until we get up to 2. Okay, that's where the efficient barista is spending all their time making espresso and the poor barista is spending all their time making milk. Now, once we get to 2, the poor barista is going to start being indifferent, right? They don't care now. So they can either make espresso or they can make milk. All right, so we're going to increase the amount of espresso in the economy, say, and decrease the amount of milk. And in fact, we're going to keep decreasing the amount of milk until the denominator here approaches 0 and the numerator approaches some number, any number. You know, and when everybody in the economy is getting close to making only espresso, then this number here explodes and this like sort of line just goes off to infinity on the right. Okay, so this line is sometimes called the relative supply line. Given the price, how much of these two different goods is supplied in the economy, okay, in relative terms. All right, now we want to draw the relative demand line, right? To find equilibrium, we want to have supply equal demand. So here we're going to have relative supply equal relative demand. Well, we know that in equilibrium, we need to have exactly the same amount of espresso as we have milk. All right, so that's going to be 1. All right, so here we have 3 halves. It means that 1 is going to be somewhere to the left of that. Let's say it's right about there. Okay, so this is going to be 1. We're just going to draw a straight line shooting up from there, and that's relative demand. Because to make a latte, you need to have exactly the same amount of milk as espresso. So if we want to, you know, make only lattes, then this will be the demand line. Okay. So what have we learned? We've learned that the equilibrium price is equal to 1. Is 1. I mean, I should have said maybe PE divided by PM is equal to 1. That's okay. Price. Let's do this properly. PE divided by PM is 1. Okay? But we learn a lot from that. What did we learn? We learned that the inefficient barista, or the poor barista, is actually not producing any espresso, right? If the relative price of espresso is below 2, the poor barista is not going to make any espresso. So we already know that the amount of time spent by the poor barista when we're in market equilibrium is equal to 0. Okay, so I'm going to say this implies that poor barista specializes in milk. All right. So now again, we know that the amount of milk and the amount of espresso is the same in equilibrium. So let's figure out how much espresso we're going to get. Okay. So we know that the amount of espresso we're going to have in the economy is just the amount of, is 60 times the amount of time that the efficient barista spends making espresso. That has to be equal to, let's see here, 60 times 1 minus T1. So that's the amount of milk that the efficient barista is going to make, plus 40, because we know the poor barista is only making milk. Okay, so let's solve for T1. We're going to get 60 plus 40 on this side, so 100. And we're going to get 60 plus 60 on this side, so 120. T1. So T1 star is equal to 5/6. All right. So how much? How much espresso are we going to get? 60 times 5/6. That means that we're going to get 50 units of espresso, or in other words, 50 lattes. Okay. So we get 50 lattes. Okay. Now, you can see that the number of lattes we get when we have the market allocation is exactly the same amount of lattes we get when we had the benevolent dictator, or the latte-maximizing dictator. So what does this say? It says that even when you have somebody that's telling everybody what they should do, like directing everybody to do, you make this many espressos, you make that many milks. This person is trying to maximize the number of lattes. It turns out that if we just let this market run, then we're going to have the same effect. Okay, so you know, you have the visible hand of the dictator sorting everybody into activities to maximize the amount of lattes. Here we have the invisible hand of the market. Okay, so this is Adam Smith's invisible hand. You know, nobody is around trying to maximize the number of lattes. The efficient barista is just trying to maximize the amount of money in his pocket, and the poor barista is doing exactly the same. And you end up with exactly the same allocation as if there were some sort of dictator that was trying to maximize the number of lattes. Okay, so this is kind of the magic of the market. This is kind of an allegory about why economists are often very positive about markets. It's because they have this feature that under certain conditions, you're going to allocate things the same as if somebody was trying to maximize the amount of allocation. By the way, I just realized you couldn't see that the equilibrium price is equal to 1 here because my head is covering up that part of the screen, so I'll just say it over here again. The equilibrium price is PE divided by PM. Maybe they could have stars. I'm not going to write that here. Equal to 1. Okay, right there. Okay, so I want to just quickly summarize here. Okay, I'm going to talk about the point. So, what's the point of this little lecture? 1, autarky is the worst. Right? People can't you can't cooperate with each other when there's autarky. Right? Cooperation is what's going to increase the size of the economic pie, if you like. All right. 2, even though the dictator can tell everybody what to do, the market does just as well. At maximizing lattes. Okay, and then as we talked about, this is Adam Smith's invisible hand. Even though there's nobody that's actually up there directing people what to do, it's just as good as if there were somebody up there directing people what to do. Okay. So, for next time, what I'm going to talk about is an important thing that I glossed over here. All right, so what we talked about was that the dictator and the market produce pies that are exactly the same size. Okay, but what we didn't talk about is what fraction goes to the efficient barista and the poor barista when we have a dictator or when we have the market. All right, they don't have to be the same. All right, so we're going to talk about the splits. See you then.